Have you ever wondered what would actually happen if someone swallowed a lit match? It sounds like a scene from a cartoon or a dare gone wrong. The image of a tiny flame traveling down into the darkness of the human body is quite vivid. Many people might instantly imagine a dangerous internal fire starting. This thought is both fascinating and a little frightening. It makes us consider the limits of what our bodies can handle. This question touches on basic biology and chemistry. It also highlights common misunderstandings about how our digestive system works. The idea of swallowing something on fire is inherently alarming. Our natural instinct is to avoid fire, to protect ourselves from its destructive power. So, the thought of willingly or accidentally ingesting a flame seems incredibly perilous. What would be the immediate sensation? Would there be intense pain? Could it cause serious, lasting damage? These are the initial questions that spring to mind. People often picture the worst-case scenario. They might think of burns, internal explosions, or other dramatic consequences. The reality, however, is often less sensational than our imaginations suggest. This common query opens up a fascinating exploration. The moment a lit match enters the mouth, several things happen very quickly. The mouth is a sensitive environment. It is lined with soft tissues called mucous membranes. These tissues are rich in nerve endings. The first sensation would undoubtedly be heat. A lit match head can reach temperatures of several hundred degrees Celsius. This heat would be immediately felt by the tongue, palate, and inner cheeks. It would likely cause a sharp, burning pain. This pain is a warning signal from the body. It tells us that tissue damage is occurring or is imminent. The intensity of this initial burn would depend on a few factors. How long was the match lit? How deeply was it inserted into the mouth? Was the flame directly touching the tissues? Even a brief touch from a hot object can cause a first-degree burn. This is similar to a mild sunburn. The area might become red and slightly swollen. If the contact is longer or more direct, a second-degree burn could occur. This would involve blistering and more significant pain. The mouth is a very vascular area, meaning it has many blood vessels. This can sometimes help with quick healing, but also means it can react strongly to injury. Saliva production would increase almost instantly, as saliva is the mouth's first line of defense. To understand what happens further, we need to look at the match itself. A typical safety match has a head made of several chemicals. The key ingredient is an oxidizing agent, usually potassium chlorate. This chemical provides the oxygen needed for the flame to burn. This is why a match can ignite so quickly and burn vigorously, even in a relatively still environment. The match head also contains sulfur, or compounds of sulfur. Sulfur helps to create a sustained flame after the initial ignition. Fillers like powdered glass can be included to increase friction. A binder like glue or starch holds these components together. When you strike a match, friction generates heat. This heat ignites the chemicals on the match head. The red phosphorus on the striking surface of the matchbox reacts with the potassium chlorate in the match head. This reaction produces a lot of heat very quickly. This heat then ignites the rest of the materials in the match head. The potassium chlorate decomposes, releasing oxygen. This oxygen fuels the combustion of sulfur and the wooden stick. The flame you see is the visible evidence of these rapid chemical reactions. Assuming the lit match, or what remains of it, is swallowed, it begins its journey down the esophagus. The esophagus is a muscular tube connecting the mouth to the stomach. It is about 25 centimeters long in adults. Its inner lining is also a mucous membrane, similar to the mouth. If the match was still hot or had sharp burnt edges, it could cause some irritation or minor scratches to this lining. However, the esophagus is quite resilient. It is designed to transport various types of food, some of which can be coarse or have rough textures. The passage through the esophagus is relatively quick, usually taking only a few seconds. The act of swallowing triggers peristalsis. This is a series of wave-like muscle contractions that move food, or in this case the match, down the esophagus. Saliva, which would have been produced in abundance in the mouth, would accompany the match. This saliva continues to offer some protection. It lubricates the passage, making it easier for the object to move. It also continues to cool any residual heat from the match. The environment within the esophagus is not conducive to burning. It is moist, lacks a significant supply of free oxygen, and the object is in constant motion. Any lingering ember would be quickly extinguished. Section 5. The stomach's embrace, acid versus ash. Once the match remnants leave the esophagus, they enter the stomach. The stomach is a J-shaped organ with a highly acidic environment. This acidity is due to hydrochloric acid, a strong acid produced by specialized cells in the stomach lining. The pH of stomach acid is typically between 1.5 and 3.5. This is very acidic, comparable to lemon juice or vinegar, but often much stronger. The primary functions of stomach acid are to break down food, particularly proteins, and to kill ingested bacteria and other pathogens. This powerful chemical environment is what greets the swallowed match. By the time the match reaches the stomach, any flame or significant heat would be long gone. What arrives is likely a small piece of charred wood and some residual chemicals from the match head. These materials are tiny compared to the typical contents of the stomach, especially if a person has recently eaten. The stomach's muscular walls churn and mix its contents. This action, along with the potent acid, begins to work on the match. The charred wood is mostly carbon. Section 6. Mythbusters, no infernos within. One of the most persistent ideas about swallowing a lit match is that it could cause a fire inside your stomach. This is a dramatic and frightening image, however, it is firmly in the realm of myth. To understand why, we need to consider the basic requirements for fire. Fire needs three things: fuel, oxygen, and a heat source. This is often called the fire triangle. If any one of these elements is missing, a fire cannot start or continue to burn. The human stomach is a very poor environment for a fire. Firstly, let's consider oxygen. While there is some gas in the stomach, often swallowed air or gases produced by digestion, the concentration of free oxygen is very low. It is certainly not enough to sustain a flame. The match head itself contains an oxidizer, potassium chlorate, that releases oxygen. However, this is a very small amount, designed for a quick burst of flame in the open air. It is not nearly enough to support combustion in an enclosed, wet, and mostly oxygen-deprived space like the stomach. The flame would be snuffed out from lack of oxygen almost immediately upon entering such an environment. Section 7. The body's resilience dealing with foreign objects. The human body is remarkably resilient when it comes to dealing with foreign objects. Swallowing a lit match is unusual, but the digestive system can handle many non-food items. Once the flame is neutralized, the match becomes just another small foreign object. The primary concern shifts to the object's physical properties and chemical composition. For a small, soft item like a wooden matchstick, the risks are generally low. The digestive tract can process a wide variety of materials. It can pass small inert objects without much trouble. Items like fruit seeds, small buttons, or coins are commonly swallowed. These objects usually travel through the digestive system and are expelled naturally. The matchstick, once charred and soaked, would be softened. The stomach acids would further degrade the wood and any remaining chemicals. The quantities involved are so small that systemic poisoning is highly unlikely. The main risks from swallowing foreign objects usually relate to their size, shape, and material. Large objects can cause blockages in the esophagus or intestines. Sharp objects like open safety pins or glass fragments can perforate the digestive tract, leading to serious complications. Section 8. Beyond the match, curious cases of swallowed items. The scenario of swallowing a lit match, while specific, belongs to a broader category of incidents involving ingested foreign objects. Humans, particularly children, are known to swallow a surprising variety of items. Medical literature is filled with case reports of unusual ingestions. Coins are perhaps the most commonly swallowed non-food item by young children. Small toys, marbles, buttons, and jewelry also feature frequently. Most of these small, smooth objects pass through the digestive system without any intervention needed. They simply travel the course and are excreted. However, some swallowed items pose more significant risks. Button batteries found in many small electronic devices are particularly dangerous. If a button battery gets lodged in the esophagus, it can create an electrical current and leak corrosive chemicals. This can cause severe tissue damage, perforation, and even life-threatening complications within hours. This is far more dangerous than a swallowed match. Sharp objects, such as needles, pins, or bones, also carry a high risk of puncturing the esophagus, stomach, or intestines, which can lead to infection and require surgical removal. Magnets, especially if more than one is swallowed at different times, can also be very hazardous. The magnets can attract each other across different loops of the intestine. Section 9. A remarkable system lessons from a tiny flame. Reflecting on swallowing a lit match reveals much about our remarkable human anatomy. The body's resilience and defense mechanisms are incredible. From pain response and saliva to stomach acids, our system handles minor threats. A tiny flame quickly snuffed out shows our internal environment's uniqueness. Fire-supporting conditions don't exist in our digestive tract. This dispels dramatic myths. Understanding basic chemistry and biology is crucial. The fire triangle explains why internal fire is impossible. Acids and mucus linings protect us from foreign materials. Swallowing a lit match can cause burns, but internal catastrophe is imaginary. The outcome is minor injury and processing of an inert object. This reminds us of the dangers of swallowing other objects. Items like button batteries or magnets pose severe threats. Distinguish between perceived dangers and actual risks. Education on real hazards is vital for preventing injuries.